guys, Savage Sullivan Math here. Today we're going to take a look at determining whether or not a point lies on a line. But I want to do it without graphing the line. So how would we do that? Well, let's say I have the line y equals 3x minus 4. And I want to know, does the point -1, -7 lie on this line? Well, I don't want to draw a graph and have to plot all of these points and see if this lies on the line because it's just too time consuming. So another way that we can do this is by checking algebraically, meaning if I take these points and I plug them in, will it be a true equation? So we know that in an ordered pair, this is x and this is y. So in my equation, wherever I see a y, I'm going to plug in -7. So in my equation, I'm going to plug -7 in for the y value. Again, I'm doing that because -7 is the y value I'm checking. Then, wherever I see an x, I'm going to plug in my x value of -1. So what's important to remember is the 3 is going to come down to x. Well, we're going to replace the x with the x I'm checking, -1. And we're remembering that when two things are stuck together in math, that means multiplication. So this is really 3 times -1. And then the -4 just comes down. And now we want to see if this equation is going to come out to be true. So we have -7 and then 3 times -1, which is -3 minus 4. What is -3 minus 4? Yep, it's -7. Does -7 equal -7? Yes, it does. So since my equation works, that means that yes, this point, -1, -7, lies on this line. Awesome. We could check it if we wanted by graphing and seeing if the point is on the line, but because we did it using algebra, we don't have to. How cool is that?
Wicked work, Mrs. Savage. Here's another example. If we have the equation of y is equal to -1/3 times x minus 4, and we are wondering if the point 6, -5 falls on this line, how could we figure out that it is in fact a point on that line, or maybe it's just not? Remember what Mrs. Savage did? She proved it algebraically. We could graph it, but boy, she's right. That's super time consuming. Algebraically, we have all the skills. That's a lot easier because then we don't need to draw the coordinate plane. All right, so here we go. Remember, in an ordered pair, these numbers are alphabetical. So this represents the x and this represents the y. So when we rewrite this equation, wherever we see an x, we're going to place the 6 instead of the x. And wherever we see the y, we're going to replace it with the -5. So for this equation, we are looking at -5, because that's our y, is equal to -1/3 times 6 minus 4. We don't lose the -1/3 and we don't lose the -4. We are just replacing our x and our y with the x and the y values here. And now we need to do some calculations. Well, there's nothing that we can simplify on the left-hand side, so that stays -5. -1/3 times 6. What is -1/3 of 6? Well, that is a -2. Don't forget about your -4. -2 minus 4 more, that's going to be a -6. Oh no. Does -5 equal -6? It certainly does not. Not here, not today. So no. This point would not fall on this line. It looks like it might be close, but it does not fall on the line. And we know that definitively because we proved it algebraically. You could also look at the graph, plot all the points, and figure it out too if you'd like. But this is enough for now. If you found this video helpful, please like and subscribe.